So here it is told that which of the following statements is wrong regarding lanthanoids. So lanthanoids, as we know, that all of them are in group number three, and in the sixth in the sixth period, and it starts from cerium and it will end at uh, lutetium. Okay, so Ln3 compounds, it means that the third valency, their valency is 3 plus. So lanthanum 3 compounds are predominantly ionic in character, which is true, and lanthanum 3 hydroxides are mainly basic in nature. That is also true, since as you know that metallic hydroxides are basic in nature, and the ionic size of lanthanum 3 ions decreases with increasing atomic number. Yeah, that is also true. Okay, so then lanthanum compounds are generally colorless, which is false, since lanthanum 3 uh, compounds have have got vacant d orbitals. So it has got unpaired electrons in the d orbitals and vacant d orbitals also. So their solutions will have some colored. So they will form colored solutions. So hence their compounds are not colorless. So here the rule is that the color color of the lanthanum compounds, it arises due to the absorption of light, due to the absorption of light in the visible spectrum, in the visible spectrum, which results in the FF transitions. FF transitions, since they have partly filled vacant f orbitals. So since they have partly filled f orbitals, which results in the FF transitions. Hence option D is the wrong statement, so it is the correct answer. Then it is told which of the following is an amphoteric oxide. So vanadium pentoxide V2O5 is amphoteric, since it can act as both basic oxide and an acidic oxide, since it can react with a base also, or it can react with an acid also. And then chromium oxide Cr2O3 is also amphoteric oxide, and Mn2O7, that is an acidic oxide, and CrO, chromium oxide, that is also an, so it is a basic oxide, and then V2O4, that is also a basic oxide. So it means that V2O5 and Cr2O3 are amphoteric oxides. V2O5 and Cr2O3 are amphoteric oxides, so option A is the correct answer. Then it is told which of the following oxidation state is common for all lanthanides. Uh, so as we know that lanthanides, they all have got valency 3, since they have ns2 and n minus 1 d1 type of configuration. So hence they can lose 3 electrons. Maximum they can lose 3 electrons. So means that the +3 oxidation state is the most common state for all lanthanides. So option B is the correct answer. Then it is told the electronic configuration of the transition element X is +3. Oxidations is uh, uh, the electronic configuration of transition element X in here it should be N +3 oxidation state is Ar3d5. What is its atomic number? So it will be argon. So it will be 4s03d5. So it is X3 plus. So it means that if we write the electronic configuration for X, then it will be argon 4s2 3d6. So hence it will, so it means that its atomic number is 28. Its atomic number is 28. No, it will be 26. Sorry, it will be 26. So option B is the correct answer. Then it is told KMnO4 acts as an oxidizing agent in alkaline medium. When alkaline KMnO4 is treated with Ki, which is potassium iodide, iodide ion will be oxidized too. So when alkaline KMnO4 is treated with Ki plus H2O in the alkaline medium, KMnO4 will react with Ki to form 2KOH. So so it will form potassium hydroxide and then MnO2 plus KiO3. So it means that here I minus means the iodide ion that is oxidized to IO3 minus ion. Here the oxidation state of iodine is +5. So it is so its oxidation state is changing from -1 to +5. So option C is the correct answer. Then it is told the elements in which electrons are progressively filled in 4f orbital are called. So 4f orbital, it means that it is of the form 6s2, 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 5f, no, 5d1 and 4f 0 to 14. So here xenon is the inert gas core. So these will be called as the 4f transition series. So it will be called the 4f transition series, or it will be called the lanthanoids. So option C is the correct answer. Then it is told the incorrect statement with reference to CE, Z equals to 58. It means the atomic number of cerium is 58. So atomic number of cerium is 58. So the electronic configuration of C4 plus, that will be xenon 4s0 3d0 4f0. So it will be C4 plus. So it will act as an oxidizing agent. So Ce in plus 3 oxidation state, okay. So here plus 4 oxidation state will be very stable, since why it will have the electronic configuration of xenon, and atomic size of Ce is more than that of Lu, then so here Ce shows common oxidation state of plus 3 and plus 4, so all these are true. But here Ce4 plus will actually act as an oxidizing agent, so it is a very good oxidizing agent. So it is not a reducing agent. Hence, option A is the incorrect statement. So it is the correct answer. Then it is told a mixture of NaCl and K2Cr2O7 is heated with concentrated H2SO4. Deep red vapors are formed. Which of the following statements is false? A mixture of NaCl and K2Cr2O7 is heated with concentrated sulfuric acid with concentrated H2SO4. Then here deep red vapors will be formed. Here the deep red vapors that are formed will be of chromyl chloride, CrO2Cl2. CrO2Cl2 is formed, and NaHSO4 and KHSO4 and H2O. So here the chromyl chloride which is formed, here the deep red vapors of chromyl chloride will be formed. So here the vapors contain a yellow solution of NaOH, that is uh, so NaOH also will react with CrO2Cl2 to form Na2Cr4 plus NaCl plus H2O, and then this Na2CrO4 is the yellow colored solution. Then this Na2CrO4, which is the sodium chromate, that will again react with lead acetate to form lead chromate and sodium acetate. This is CONa. So here the lead chromate is forming the yellow precipitate. So the vapors contain CrO2Cl2 only, and the vapors give a yellow solution with sodium hydroxide, which is sodium chromate, and the vapors when passed into lead acetate in acetic acid gives a yellow precipitate. So it gives a yellow precipitate of lead chromate. So it means the vapors will not contain Cl2. So hence option C is the wrong statement. So it is the correct answer. Then here it is told which of the following statements is wrong. The highest oxidation in highest oxidation states, the transition metals show acidic character. Then all elements of 3D series exhibit variable oxidation states. Okay, so all elements of 3D series exhibit. Okay, so all elements of 3D series will not exhibit variable oxidation state, like zinc. Zinc will only show +2 oxidation state. It will not show any other oxidation state. And zinc is a 3D transition series. So hence option D is the wrong statement. So it is the correct answer. And all the remaining statements are correct only, which are in highest oxidation states, the transition metals will show acidic character. Mn3 plus and CO3 plus are oxidizing agents in aqueous solutions, and metals in highest oxidation states are more stable in oxides than in fluorides. Okay. So all these statements A, B, C are correct. Only option D is the wrong statement. Then here it is told aqueous solution of a salt A forms a dense white precipitate with BaCl2. So here, as you know, that sodium sulfite in the aqueous solution that will react with barium chloride solution, and it will form barium sulfite, which is a white precipitate, and with NaCl. And this barium sulfite, which is a solid precipitate, that will react with that precipitate will dissolve in dilute hydrochloric acid to produce a gas B, a gas. So here BaCl2 is formed and SO2 gas is formed plus H2O is formed, and then the gas B will decolorize acidified KMnO4, and here this BaCl2 it is soluble in water, so the white pre precipitate will disappear. So the white precipitate disappears, and this SO2, the sulfur dioxide gas, that will react with MnO4 with KMnO4 solution, which is acidified KMnO4, to form Mn2 plus. So here MnO4 minus ion will react with SO2 to form sulfate ion, and then H plus. So here H2SO4 will be formed, and Mn2 plus ion will be formed. So it will decolorize the KMnO4 solution. So here it means the aqueous solution of the salt which is used, um, that is the sodium sulfite, and the gas which is formed is sulfur dioxide. So so it means A is Na2SO3 and B is SO2, but in option D SO2 is there, but instead of BSO3, if they had written Na2SO3, then only it would have been correct. So here none of the options are correct. Then it is told identify the set of paramagnetic ions among the following. Now paramagnetic ions means, paramagnetic it means that which have got some unpaired electrons, which has one or more unpaired electrons, that will be paramagnetic. So here the electronic configuration of Ni2 plus, as we know, that is equals to um, argon 4s0 3d 8 3d8, and Cu2 plus configuration is electronic configuration is argon 4s0 3d9, and then the electronic configuration for Zn2 plus is argon 4s0 3d10, and the electronic configuration of Ti3 plus, that will be argon 4s0 3d1, and Mn3 plus configuration is argon 4s0 3d4. Then configuration of sc3 plus, that will be equal to same as argon only. And electronic configuration for v3 plus, that will be equal to uh, argon 4s0 3d, so it will be 3d2. And then the electronic configuration for cobalt, so it means that v2 plus configuration will be argon 4s0 3d3. And electronic configuration for ti4 plus, that will be obviously okay. Electronic configuration for ti4 plus, that will be argon 4s0 3d ti4 plus, okay, so 3d0 also, so it is same as that of argon only. Then electronic configuration of CO2 plus, electronic configuration of CO2 plus, that will be equal to argon, then 4s0 3d7. So here it means that nickel, copper, and zinc, these three are not paramagnetic. So nickel and copper, Ni2 plus and Cu2 plus are paramagnetic since they have got unpaired electrons. Here, nickel, it has got two unpaired electrons, and copper has got one unpaired electron, and zinc has got no unpaired electrons. So zinc is not paramagnetic. Zinc is not paramagnetic. It has no unpaired electrons. And Ti3 plus, it has got one unpaired electron. Mn3 plus also, it has got four unpaired electrons, and Sc3 plus has no unpaired electron, and V3 plus has got two unpaired electron, and V2 plus has got three unpaired electrons. And then Ti4 plus has got no unpaired electron, and CO2 plus has got three unpaired electrons. So Ti3 plus, I can say, and CO2 plus, I can say, and Mn3 plus, these three have got unpaired electrons. So these are the three paramagnetic ions: Ti3 plus, Cu2 plus, Mn3 plus, Ti3 plus. They are paramagnetic ions, and Sc3 plus is not okay, and Ti4 plus is also not paramagnetic. Eh, Ti4 plus is also not paramagnetic since it has no unpaired electrons. So it means that only option B has got all three paramagnetic ions. So option B is the correct answer. Then it is told that how many moles of acidified K2Cr2O7 is required to liberate 6 moles of I2 from an aqueous solution of I minus. How many moles of acidified K2Cr2O7? Acidified is required to liberate 6 moles of I2 from aqueous solution of I minus. So here I minus will be oxidized to I2, and K2Cr2O7 here means Cr2O7 2 minus ion, that will be that will be reduced to Cr3 plus ion. So here it means we have to balance it in the acidic medium. In the acidic medium, we have to balance this ionic equation. So here 2I minus will give I2 plus 2 electrons, it will give. So here we have oxidation, and then Cr2O7 2 minus, that will form 2 Cr3 plus ions, and here oxygen is not there, so here we have 7 oxygen atoms, so here we have to add 7 H2O, and here we have to add 14 H plus ions, and uh, here chromium is in 6 plus oxidation state, here it is in 3 plus, so here it should gain 6 electrons to form 2 Cr3 plus. Now this also I should multiply with 3 and then I should add it. So then the number of the electrons will get cancelled, and then we will have Cr2O7 2 minus, then plus 6I minus plus 14H plus, that will give 2 Cr3 plus 3I2 plus 7H2O. So here it means that 6 moles of I2. So how many moles of K2Cr2O7 is required? So 3 moles of I2 is formed from 1 mole of K2Cr2O7. So it means that 6 moles of iodine is formed from 2 moles of K2Cr2O7. So 2 moles is required. So it means that option D is the correct answer. Then here it is told that Cu2Cl2, or in the previous question, we can also solve it by using the law of equivalence. So here we have to say that the number of equivalents, we can say that the number of equivalents of K2Cr2O7 that should be same as the number of equivalents of I2. So now here for I2 the valency factor is 2, since why it is uh, since why here 2 electrons has been lost by 1 in 1 mole of I2, and here in C2 or Cr2O72 minus, here 6 electrons are being transferred, so the valency factor of K2Cr2O7 will be 6 here. So now therefore, as we know that the number of equivalents that is given as the number of moles times the valency factor. So therefore the number of equivalents of I2, here it is told that 6 moles of I2 has been liberated, 6 moles of I2 is formed. So 6 moles of I2, the number of moles of I2 into the valency factor, which is 2, that will be equal to the number of moles of K2Cr2O7, let it be X, into the valency factor of K2Cr2O7, which is 6. So then 6 and 6 will cancel out, X will be equal to 2. So it means that 2 moles of K2Cr2O7 is required. So option D is the correct answer. Then it is told that Cu2Cl2 and CuCl2 in aqueous medium, Cu2Cl2 and CuCl2 in aqueous medium, the stability of Cu2Cl2 is equal to stability of CuCl2. No, it is wrong. Both are unstable, but the rule is that Cu plus its electronic configuration is argon 4s0 3d10, and configuration of Cu2 plus ion is argon 4s0 3d9. So it means that 3d10 has got fully filled electronic configuration. So therefore Cu plus ion is more stable than Cu2 plus ion and Cu2 plus. So in Cu2Cl2, here copper is in in +1 oxidation state, and in CuCl2 copper is in +2 oxidation state. So it means that Cu2Cl2 is more stable. So it is more stable than CuCl2. Okay. So which is so it is actually expected. It is expected that Cu2Cl2 is more stable than Cu2Cl2. But the thing is, but here there is one exception, that CuCl2 is more stable than Cu2Cl2, since CuCl2 has got smaller size. It has got smaller size, and hence it has got high hydration and enthalpy. So it has got high hydration enthalpy. Since here the size of the cation is l- lesser, here in Cu2, in CuCl2, Cu2 plus ion is used, whose size will be lesser than here. The size of the here the uh, cation is Cu2 plus, so it has got low hydration enthalpy since its size is higher. So hence, since the cation size of Cu2 plus is having lesser size, so it is having high hydration enthalpy. So CuCl2 is more stable than Cu2Cl2. So option D is the correct answer. Then it is told that which of the following does not represent p- property stated against it. So here's the rule is that on moving from left to right, on moving from left to right, here the here since the atomic n- number of the transition elements, since here the atomic number of the transition metals gradually increases from left to right, so here the effective nuclear charge will increase. Effective nuclear charge increases, and hence the size decreases from left to right. Uh, so here, as we know that the the 3D transition series, the 3D transition series is given as it is scandium, then titanium, then vanadium, then chromium, m- manganese, then iron, cobalt, n- nickel, copper, and zinc. So here it means that the size of cobalt, so here cobalt, Fe, and Mn. So here the size decreases. So yeah, cobalt size will be CO2 plus size will be lesser than Fe2 plus, less than Mn2 plus. Since why, as we go towards the right, the size, the ionic size also will decrease. Ionic size also decreases. Then here, um, as you know that Mn shows the maximum number of oxidation states, which is shows +2, +3, +4, +5, +6, and +7 oxidation states. And vanadium, it shows oxidation states +2, +3, +4, and +5. And titanium, Ti, titanium shows oxidation states +2, +3, and +4 only. So it means that the maximum number of oxidation states shown by is shown by Mn, then less than that is vanadium, and less than that is titanium. So titanium shows the least number of oxidation states. So B is also the correct. So option A is also the correct statement. B is also the correct statement. And here in option C, it is told the order of the uh, paramagnetic behavior is this paramagnetic behavior order. So now it is told chromium 2 plus and Mn 2 plus and about Fe 2 plus. So their electronic configurations for Cr 2 plus, that is mm, so it is 4s03d4, that is means argon 4s03d4, so it has got 4 unpaired electrons. And Mn2 plus, it has got it is argon 4s03d5, so it has got 5 unpaired electrons. And for Fe2 plus, it will be argon 4s03d6. So here it has got 4 unpaired electrons here. So it means that Mn2 plus will have the maximum paramagnetic behavior. So Mn2 plus has the maximum paramagnetic behavior, but here it is showing saying that Fe2 plus has the maximum paramagnetic behavior, which is wrong. So option C is the wrong statement. And then Sc, Cr, and Fe is the density order. It is told that for scandium the density is higher, but the actual density order, is Fe more than chromium more than scandium, Fe more than chromium more than scandium. So scandium will be lesser than chromium more than iron. So it means that it is the reverse order which has been told. So C and D both are wrong statements. So option C and D both are the correct answers. Then it is told which of the following is correct for all elements from Sc to Cu. The lowest oxidation state shown by them is +2. So here Sc can show +1 oxidation state or +2 oxidation state or +3 oxidation state, and copper it can show +1 or +2 oxidation states. So it means that +1 is the least oxidation state shown by them. So option A is the wrong statement. 4s orbital is completely filled in the ground state, which is uh, which is wrong. Since why? In case of Cu, the electronic configuration of for Cu is argon 4s1 3d10. So here 4s orbital is not fully filled in the ground state, and 3d orbital is not completely filled in the ground state. That is also wrong, since why 3d orbital is fully filled in the ground state for copper. And uh, the ions in +2 oxidation states are paramagnetic. Yeah, so for Cu2 plus, the it has got one unpaired electron, since its configuration is 4s03d9, so it has got one unpaired electron, so it is a paramagnetic ion. It is a paramagnetic ion. So, and Sc2 plus also, it has got one unpaired electron, since its configuration will be argon 4s03d1, so it has also got one unpaired electron. So hence option D is the correct statement. Then here it is told which of the following has both the ions colored in aqueous solution. So here the rule is that an ionic for an ionic species for an ionic species of a transition element for an ionic species of a transition metal to be having a colored aqueous solution to be having colored aqueous solution is that it should show is that it should show dd transition should show dd electronic transition. So it means that it means it should have um, partly filled d orbitals. It should have partly filled it should have partly filled d orbitals. So it means that if it has no d electrons, or it has fully filled d electrons, or it has fully filled, mm, o- or I can say if it has vacant d orbitals, or it has got fully filled d orbitals, then only its aqueous solution will be colorless. Then only its aqueous solution will be colorless, since in that case there will be no dd transition. There will be no dd transition in that case. Now here we need to find which ones will have unpaired d electrons. It means that half filled d o- orbitals. So now the e- electronic configuration for scandium, the electronic configuration for sc3 plus, the electronic configuration for sc3 plus, so that will be same as that of argon. So it will have no dd transition, it has no d electrons, so its solution will be colorless. So it will have colorless aqueous solution. So we need to find which of the ions has are colored in the aqueous solution. So it means that option A is obviously wrong. And for Mn2 plus, it will have the electronic configuration as argon 4s0 3d5. And then the electronic configuration for Ni2 plus, that will be argon 4s0 3d8. So it also has two unpaired electrons. And in Mn2 plus also it has got 5 unpaired electrons. And then Ti4 plus, its electronic configuration is same as argon only. So it has got no unpaired e- electrons, so it will have colorless aqueous solution. But in case of Mn2 plus and Ni2 plus, here the solution will be colored. Here we will have colored aqueous solutions. And then in the case of Ti3 plus also, the electronic configuration will be argon 4s0 3d1. So here also it will have one unpaired electrons, so it will also be having colored aqueous solution. Then Cu plus will also have the electronic configuration Ar argon 4s0 3d9. So here also it has got one unpaired electron, so it will also have colored solution. and Mn2 plus, as I told. Okay, so Mn2 plus and Ti3 plus, Mn2 plus and Ti3 plus, they will have colored solutions. Then Ti3 plus, so sorry, in Cu plus it will have 3d10, so it has no unpaired electrons, so it will have colorless solution. So Mn2 plus and 3 and Ti3 plus will have unpaired electrons, so it will have colored solutions. So option D is the correct answer. Then here it is told a transition metal exists in its highest oxidation state. It is expected to behave as an, it will obviously behave as an oxidizing agent. Like manganese, in Mn2O7, manganese, or in case of KMnO4, here Mn is in +7 oxidation state, which is the highest oxidation state. So here it can, it will behave as a very good oxidizing agent. Very good oxidizing agent. So it means that option A is the correct answer. Then what will be the value of x in Fex plus if the magnetic moment mu equals to root over 24 Bohr magneton? So the magnetic moment mu equals to root over 24 Bohr magneton. So it, as you know that mu equals to root over n into n plus 2 Bohr magneton, where n is the number of unpaired electrons. N is the number of unpaired electrons. So here it means that 24 equals to n into n plus 2. So from here we can see that n should be equal to 4. So it should have 4 unpaired electrons. Now Fe can exist as Fe2 plus state or Fe3 plus state. Now the electronic configuration for Fe2 plus, that will be argon 4s0 3d. Now as we know, okay, 3d6. So here it, so here in the d orbitals, it has 5 orbitals, so 6 electrons. So it has got 4 unpaired electrons. So here n equal to 4, and in case of Fe3 plus, the electronic configuration will be Ar 4s0 3d5. So here it has got 3, it has got 5 unpaired electrons, so n equal to 5. So hence here Fe should be in the 2 plus state. So Fe2 plus it should be. So hence x should be equal to 2. X should be equal to plus 2. So option C is the correct answer. Then it is told the only lanthanoid which is radioactive is that, so that is promethium. Which promethium, its symbol is Pm. Mm, no, it is Pr. Pr. So promethium is the only lanthanoid that is radioactive. Only lanthanoid which is radioactive. So option A is the correct answer. Then it is told all Cu2 plus Cu means copper 2 halides. It means here the valency of copper is 2, so it means that it is in the Cu2 plus state. Now copper 2 halides, it means that it is of the form CuX2. So copper 2 halides are known except iodide, means CuI2 is not known. The reason for that is when cupric iodide is formed, it is highly unstable, so it can easily decompose. It can easily decompose into cuprous iodide Cu2I2 and I2. So Cu, the reason is that Cu2 plus oxidizes this iodine I minus ion, means Cu2 plus will be reduced to Cu plus ion, and I2 means the I minus will be oxidized to I2. So Cu2 plus will oxidize the iodide ion into iodine, where the oxidation state is 0 here. So option D is the correct answer. So hope all of you have understood the solutions of all these questions based on the previous year KCET exam on the chapter D and F block elements. Still any doubts if you have, please write that in the comments. We shall obviously clarify them in the subsequent videos. Also please install our Sapience education application, where we shall upload some important questions on every chapter of chemistry which are based on the previous year KCET exam, which shall be obviously helpful for your exam. So thank you everyone. Bye.